Good morning, good afternoon, good evening, depending on where you're joining us from. Welcome to Simplilearn. We are honored to have you join us today for Spark versus Hadoop with your host, Jamin Patel. My name is Richard, and after this intro, I'll be mostly in the background helping Jamin so that everything goes smooth, and then I'll come back in for the last 15 minutes of question and answers, and I'll be going through those as they come in. Spark versus Hadoop. As the two biggest players in big data analysis, who are they? How are they different, and how are they the same? What do all these terms like RDD and RDBMS mean? From a career point, what studies and certifications will serve the best moving you forward in your own life? And from a business standpoint, which one should be used for what? Spark versus Hadoop. If you do not know Jamin Patel, Jamin is a hands-on, performance-driven software professional with over 11 years of experience. Specialized in object-oriented design and analysis with extensive experience in Java, J2EE technologies, big data processing and analytics using Hadoop, MapReduce, machine learning, Mahout, R technologies, Spark, ML library, streaming, SQL, graphics. We are lucky to have his experience today, and I hope you've brought lots of your own questions for him. We'll collect those and answer those at the end of the session. You didn't come here to listen to me. I'm proud to introduce Jamin, who will be your host for Spark versus Hadoop. Go ahead and sit back, relax, have a cup of coffee, tea, or maybe it's evening where you're at, and enjoy a glass of Merlot or wine. It's an honor for me to hand this over to Jamin. Hello, Jamin. Welcome to today's webinar on Spark versus Hadoop.
Richard, hi, I'm here.
A little trouble with the microphones clicking on there. It's an honor for us to have you. Thank you for being here today, Jamin. Greatly appreciate you being here today.
Thank you. Thank you, Richard. Appreciate, and thanks for again joining and hosting the show along with me. Thank you. So, hello everyone. Richard has already talked nice words about me, so I'm really honored. Thanks, Richard, for those very warm welcome introduction. So today we are going to talk about Hadoop versus Spark, right? This webinar is mainly focusing on comparison between Hadoop and Spark, and we are going to understand why are they, why are they coexist, or do one replace another, right? There are a lot of such questions that people would have, and the basic questions that I'm hearing always is, now the Spark is there, what is the need of Hadoop, right? Or does really Spark is able to completely replace Hadoop, or still you need Hadoop? So we are going to actually focus our webinar on understanding that, and we are going to understand some of the key motivation, or rather key objectives why Spark was developed, right? So I'm going to also walk you through the white paper published by University of California, Berkeley. They are the ones who have pioneered Sparks, who are the ones who actually developed Spark, and they have mentioned it detailed out the reasons why Spark was needed, right? So we are going to understand those reasons as well, right? So to start with Spark and Hadoop, let me first give you a very brief comparison in a big data stack. Where do they fit in, right? So that we can actually compare them in a much more easier manner, right? So first of all, I would like to help you understand that these are the big data stack for us, and there are various components available in big data stack. So I would love to mention a couple of components which both Spark and just a second. Okay, Spark and Hadoop provide. So let me just walk you through those components. So we have HDFS, we have Yarn, we have MapReduce, right? These three are the core components of Hadoop. When you install Hadoop, you get these three core components, right? These are part of Hadoop. Now, we are not really going to spend a lot of time in understanding what Hadoop provides, but I would still give you a brief idea about what Hadoop provides. So Hadoop is a framework which helps you to store big data in an efficient and a distributed manner. So it is actually having a component which is called Hadoop Distributed File System, where it helps you to store data in a distributed manner. And it also helps you to provide the capability to process this data in a parallel and a distributed manner. So we have two core components, HDFS and MapReduce from Hadoop, which helps you to do storage and processing of big data. Hadoop also provides one more layer called Yarn, which is doing cluster resource management to provide better resource management across the cluster so that the jobs that you run on Hadoop cluster get better resources and it gives you better performance. So that's about Hadoop. These are the three core components that Hadoop provides. Okay. Now you have a lot of ecosystem components developed, and I'm not really going to discuss that right now, but still, just to give you an idea, we have Pig, we have Hive, we have Mahout. These are the components which are developed on top of MapReduce. So I would call this as a MapReduce family. Okay. I will also talk about MapReduce and Spark in comparison. So first of all, we really want to understand where Spark and MapReduce fits together, right? So we have MapReduce here, then we have, let me just draw it in a color which is probably a different color. So let me write it here, Spark. This is Spark SQL. This is Spark Streaming. You have Spark Graphics, and you have MLlib. Okay, so this is a Spark family. Now, if you notice here from the diagram that I have fit in, anybody would easily understand that Spark is not a replacement of MapReduce. Okay, Spark will replace one of the layer which is a processing engine of Hadoop, which is, we call it as MapReduce, and it has equivalent ecosystem components so that it is going to replace these components as well with these components. But underlying layer of Hadoop can still be used along with Spark. So Spark provides just a processing engine. Okay, the resource management and the storage layer can still be used or leveraged from Hadoop, and that is why I said Spark is not a replacement of Hadoop. However, to run Spark, you don't need Hadoop. So Spark is not dependent on Hadoop. Spark can actually, it's an independent processing engine which you can install on any distributed file system. It could be HDFS, which is provided from Hadoop. It could be NoSQL databases, or it could be any other local file system storage. Spark also comes up with its own cluster resource manager, right, which is equivalent to Yarn. Well, it is not exactly equivalent to Yarn because it is not very matured. Yarn is very powerful and matured resource manager, whereas Spark has a standalone, or we call it as local resource manager, okay, which will be similar to Yarn, but it would not be used in a production environment, right? So generally people use Yarn, or there is one more resource manager called Mesos. Now you might be wondering that I'm actually bringing out a lot of terms here, right? And I don't really want to discuss all these components here. We just want to focus and limit our discussion between Spark and MapReduce. So as I just briefly explained, Spark is not a replacement for Hadoop. Spark is a processing engine which is going to replace a processing engine from Hadoop, which is MapReduce. Okay, and the primary advantage why Spark is going to replace a processing engine of MapReduce, which is basically because Spark provides performance which is 10 times faster than MapReduce on the disk and 100 times faster on network or memory, right? So we are going to first understand what was the need of developing Spark. Why was there a reason why Spark was developed? Why was MapReduce not enough or capable solution to process big data? What were the challenges with MapReduce? Once we understand that, we would be able to appreciate Spark much better, right? And that's how we should start our journey with Spark, or rather any technology. Whenever you want to learn any new technology, the first basic question you should ask is, why is that needed? What kind of problem does it help me solve, which other technologies which are in the same domain cannot solve? Once you understand that, that's it. Then you will be able to appreciate it much better. So let's start our journey with that. I'll be parking this discussion aside. Right now, just assume that it is going to be replacing MapReduce, and it has its own ecosystem components which are going to replace these components of MapReduce. Okay. Now let me start walking you through some of the white paper discussions, and I would be spending some time on explaining you that as well, which is, uh, which is a very good paper which is detailed out by the University of California. So they have mentioned that what was the reason why MapReduce was not efficient. What are the use cases where they thought that MapReduce is definitely not giving you better performance. So let me explain those use cases. And the first use case which they detailed out was iterative jobs or iterative analytics, right? And the second one is interactive analytics. If we understand these two, we will understand why Spark is needed. Okay, so let's start with that. So let me explain you these two use case. First is iterative analytics. Okay, now why do we need, what is iterative analytics? First of all, we so the statement here is MapReduce is not efficient to solve problems which requires iterative analytics, and Spark gives you better performance here. But before we understand that, let's understand what is iterative analytics. So iterative analytics in a layman's definition is running a same program on the same data set again and again to improvise on the findings that the program gets as an output, right? So in a very layman's term, it's just about you are running the same program on the same data set in an iterative manner. Now, any rational person would ask this question, why do I need to run the same program on the same data set multiple times, repeatedly? Can I not get the output first time? That is what program is supposed to do, right? So that is what is a question that people would have when we talk about iterative analytics. And actually, iterative analytics is one of the major area in machine learning. A lot of machine learning algorithms are in fact developed and are in fact working with iterative analytics. They are using iterative analytics to solve problems, to build models. So we want to understand what exactly is iterative analytics, and I'll be giving you an examples through which we will be understanding that, right? So let me spend few minutes on explaining what is exactly iterative analytics. I will be giving you or sharing you the use case which I have worked on when I was working with one of the company, and we had developed a platform where we were actually doing iterative analytics for solving one very interesting case study. So let me quickly brief you about what we have done. Okay, so this company was actually getting a lot of financial transaction data of billions of registered customers from various banks of USA. Okay, banks like Bank of America, Chase, Citibank, all the big banks were their customers, and they were, and all the users who are registered for these banks, who are using these bank services, their data, their daily transaction data, we used to get it in our databases. Okay, why do we get it? How do we get it? That's a different story. Let's assume we were running some product which is a flagship product through which we were getting those transactions. So we were getting all these millions or millions of transactions on a daily basis. We used to get about approximately 13 million transactions, okay, just for a credit card and a debit card transaction. Okay, I'll call it credit or debit. So bank and card transactions is what we used to get. Combining these two, we used to get about 13 million transactions for approximately 5 million users. Okay, so now we were shipping this data. We were doing a lot of such. We were generating this data, by the way, in our databases. And I'm just talking about two containers. We had loan, investment, a lot of other containers through which we were generating data. Now, what I'm trying to highlight a point here is we were having a lot of financial transaction data, and our team had come up with an idea to generate analytics on top of that and sell these analytic services to the hedge fund companies who wants to predict market trends. For example, these companies are expert in finding out what will be the Walmart stock price tomorrow morning, what will be the Walmart stock price. But to predict that, they were actually running interesting high frequency trading algorithms, and to make their algorithm predict accurate price, they need to train their algorithm, and for that they need a data, accurate data. Now if I want to find out whether Walmart stock is going to go up or down, the best way I can figure it out is how many people are doing transactions at Walmart, right? So since this company had all the transactions data of the users, they were actually getting all these millions of transaction records, and they wanted to analyze this to find out how many of them belong to Walmart on a daily basis, and then they will try to analyze this on a weekly or monthly basis and find out that what is an overall sales of Walmart on a periodic basis, whether it is going up or down, and that would be a very clear indicator for them to find out whether the price of the stock of Walmart is going to go up or down, right? So it is very critical for them to find out which transaction belongs to which merchant, right? They were actually hitting on predicting the prices for top 500 merchants in US, and they wanted to know how many people are shopping at those 500 merchants, right? So since we were getting all the transactions data of different users, see, whenever I buy, let's say at Walmart, or if I shop at McDonald's or JCPenney, if I shop for $100, my card statement will say this is the transaction, and I have shopped at JCPenney for $100, right? Now when you get this transaction, we as a user will easily find out because we know that we have done that transaction, right? But as a system will just get to know that this is the transaction description, and that description will have unstructured text which mentions JCPenney somewhere and which mentions the dollars and all that, right? Now from that amount we need to find out what is the right merchant. So in our data we never had a different column which says this is the merchant name. Generally banks don't give you a separate column in your account statement which says this is the right merchant, right? I'm sure all of you who are doing transactions, that you know that when you read your statements, bank statements, you will know that there will not be a separate column which says what is the right merchant, whether it is Walmart or JCPenney or whatever. Now imagine that if I'm sure you will all agree that different banks will also have a different way to represent a merchant. For example, if I'm having a credit card or debit card of Citibank, and if I buy at, let's say, Walmart for $100, and then next day I will use, let's say, Bank of America card, and I buy the same product $100 at Walmart, in my both the accounts will have a statement, but one bank will say $100 at W-Mart, another bank will say $100 at Walmart, third bank may say WMRT, right? So what I'm saying is different banks will represent different each merchant in a different way. There is no standardization, and that is where it becomes a very difficult problem to find out whether this transaction belongs to the Walmart or not. So this was our problem statement, and hedge fund companies were really interested in knowing the right merchants, and they wanted to give us this business. So we had to do that, and hence we have used a machine learning algorithms. We have used a clustering technique to solve this problem. Now I'm not really going to help you understand how did we do that, but the reason why I am briefing this use case so that we will understand what is iterative analytics. Okay, so what we have done here, we have, in fact, I'll just quickly brief you. So we were told that we have to categorize all the daily 13 million transactions. We have to find out the right merchant for each transaction, and we have to, in fact, find out all the transactions which belong to top 500 merchants. So they have given us the list of top 500 merchants. And they were also telling us that if any transaction which does not belong to any of these 500 merchants, then it is okay if I say it is uncategorized. But if it has a transaction of Walmart, and if I don't say it's a Walmart, that's a big business loss for them. So I have to be very accurate in saying that this transaction belongs to Walmart, and that is why we had to use a machine learning technique. And generally in any machine learning, what normally you do is you have huge data, right, which is called training data, which you supply to your algorithm, ML algorithm, okay, which will learn the patterns and build the model out of it. After that, you supply training test data to this algorithm. An algorithm will use this model to predict the result out of it. Okay, This result you will do validation on and find out the accuracy of your model. This is the cycle that you have to keep on repeating, okay, till you perfect your model, till you are satisfied with the accuracy of your model. And generally people consider above 95% is a good accuracy, but it varies, depends on the business and the domains. Now what I'm trying to highlight a point here is, in any machine learning activity, you have to train your models. You train your algorithm to build a model, and you have to perfect your model. You have to validate your model. Once you are satisfied with the accuracy, you will deploy this model in productions, and algorithm will use that model to predict any data item in production. Okay, so this was the activity that we had to do. We have used a clustering algorithm to solve this problem. Now, as I said, we had to cluster all the transactions data into top 500 merchants. So we had these clusters of 500 merchants. I'm just giving a cluster, means just assume that they are temporary files. Okay, they are files, and we have tagged each cluster as Walmart, JCPenney, Amazon, maybe this is McDonald, you can just give some other name, which could be, let's say, Domino's, whatever. So there are various merchants, and we wanted to actually find out the right model for this. Now, the clustering technique, how does it work? So it will first find out the centroid of each cluster. It has to fix that. For that, we have to train that model, and for that we had actually supplied last 1 year of data, every day 13 million into 365. So imagine that many billions of transaction data we had to supply to this algorithm, so that algorithm will learn the pattern and build the model out of it. So imagine, so this transaction data, we had to convert it into a vector. When I say vector on an XYZ plane, you can understand it as if it is a, on an XYZ plane, right? You can assume that a vector is a point. Let's say this point has XYZ coordinate. Similarly, each point has an XYZ coordinate. It's a mathematical point now. How do we convert a normal transaction record, a text record, into this mathematical point? That's a very big area in data science, right? So we'll not discuss that right now, but assume that we have to work with data scientists to get this. Once we have this, then what algorithm does here? So again, let me tell you one thing. We are not really understanding how algorithms solve this problem. We are understanding what is iterative analytics, and that is why I'm presenting this case study. So here, what has algorithm done? It has actually first randomly assumed the centroid of each cluster. Okay, and then try to find out the distance between. Then what it does, after assuming the centroid of each cluster, it will try to find the distance between the centroid of the Walmart with each of the point which is there on the plane, XYZ plane, right? And try to find out which points are closer to this centroid. So the centroid will move towards that, right? So imagine, actually in this diagram, ideally the centroid will move, but let's assume that the points are coming closer. We'll just assume that way. Similarly, it has done it for all the other clusters, and you can see that the points, it will try to group the points which are closer to the centroid of that cluster. Now this is called one iteration. All right, this completes first iteration. Now when you complete first iteration, after that the algorithm will redo the same activity again. Okay, and it goes for the second iteration. Now the question is, why does algorithm have to go for the second iteration? Why can't it say that the points that it has found out are the perfect point for this cluster? It has to do the second iteration because the first iteration, remember, we have assumed the centroids. The centroids were not permanent, were not fixed. We have assumed that. So anything which is based on assumptions, we can't really rely on that. So we have to perfect the centroids. We have to fix the centroid, and that is why algorithm will redo this activity. It will recompute the centroid of these points again, and based on that it will try to find out the distance between each points. Now my diagram looks a little weird for you. That's fine, don't worry, just try to understand the concept. So what I'm trying to highlight a point is, in the iterative analytics, this algorithm, the clustering algorithm, does this iteration, does this, it has to perfect the centroids, and for that it has to rerun this iteration again and again to finalize the centroid. And the question is now, when does it stop? So it will stop when the centroids are not moving from the previous iteration, right? Then it will say, yes, now I have finalized the centroid. That is where it stops. So this is called iterative analytics, right? This is one of the example of iterative analytics, so that all of you can easily understand what do we mean by iterative analytics. Now, most of the machine learning algorithms are iterative in nature, and they would need iterative analytics to solve any problem. And that is the major area in any data science, any data analytics that you do. You will need those, you need to do iterative analytics. And that is where University of Berkeley, they found out that, okay, if we want to do iterative analytics, we have a MapReduce as one of the, a technique of Hadoop to solve this problem, right? So let us understand a little bit on MapReduce. Now, I'm not really going to cover the architecture of MapReduce in the interest of time. I'm just assuming that you know a little bit on that, but let's understand this way. Let's say I will still give you a brief idea on that. So we have a MapReduce, and MapReduce works in three phases: map, shuffle sort, and reduce. Okay, so you have certain data in the disk. The map phase will read the data from the disk, process the data, and write the output into the disk again. Then the shuffle and sort read that data from the disk, does some merging, and then finally write the data into the disk. The reduce will also read the data from the disk, does some processing, and finally write the output into the disk. Now you may have a question, what is there in MapReduce? If you don't know MapReduce, don't worry about it. Just assume that it has three phases, and you have certain logic that you need to define as a developer in these two phases, map and reduce, and the framework executes it accordingly. But ultimately it helps you to process the data. Now imagine I want to do iterative analytics, the clustering algorithm, I want to implement it using MapReduce. In that case, this is what happens in the first cycle, first iteration. This is actually first iteration, iteration 1. In that, we are going to the disk at every stage of MapReduce, right? Map, shuffle, sort, and reduce. Now imagine if it is an iterative analytics, for each iteration, we have to go to the disk, right? You have map, shuffle, sort, and reduce. It goes to the disk, read the data. It again goes to the disk, read the data, goes to the disk, read the data. This is iteration 2. Likewise, we have iteration 3, iteration 4, and there could be n number of iteration which will do the same thing, right? So every stage of each iteration we are going to go to the disk in MapReduce and do the operation. So there will be tremendous disk IO at every stage of MapReduce, and imagine there are n number of such iterations. That means there are so many stages which will happen, and every stage, if you go to disk IO, the overall performance of your program is going to be very, very slow. And that was the major concern. That was the bottleneck of MapReduce framework. That was the limitation. The MapReduce framework cannot help you get the processing faster, because in iterative analytics, you have to do multiple iteration, and MapReduce goes to the disk at every stage. This was the primary reason, primary alarming reason why University of Berkeley thought that we are not really going to, MapReduce basically is not really going to help us do the iterative analytics in a much more faster manner. And we definitely need an alternative solution in terms of some framework, and they named it as Spark, to basically process the data in a much more faster manner. And that's how Spark came into existence. So this was the motivation of why Spark was developed. So their primary school of thought was, instead of going to the disk and processing the data at every stage, you just read the data into the disk and then try to keep it in the memory. We call it as RAM. Try to keep all the data in RAM, and then the last output will be stored in the disk. Every iteration, you just try to hold the data into the memory. Okay, now this is where you are trying, by design, the framework is designed in such a way that it does a lot of in-memory processing, and hence it is actually going to do the computation much faster than MapReduce, and that is the primary selling point of Spark over MapReduce as a distributed processing engine. Okay, now you may have a question with this explanation that what does it mean that Spark can hold all the data in memory? And it would not be practically possible, because if there is big data, we will not be able to hold all the data in memory throughout the life cycle of the program. So that is a true statement. Spark doesn't really be able to hold data into the memory all the time unless your cluster has a lot of memory. So Spark definitely try to spill over to the disk in between, right? When the data is not used for a longer period based on the LRU policy, least recent use policy. So it is trying to have Spark has a capability to do intelligent memory management, and that's how it tries to free up the memory when it is acquiring full memory. And that's how it tries to make sure that all the data which needs current processing should be in memory, and the older data should be removed which is not needed. So it will definitely spill over to the disk, but the ratio of spilling over to the disk compared to MapReduce is very low, and that is why Spark is actually very efficient framework. It also has concepts like caching, lazy evaluation, and lazy execution and it executes data in the form of DAG, and that is why Spark is actually performing much faster and better than MapReduce. Right now, we are going to understand detailed architecture of Spark in the actual Spark training, and we would really welcome all of you to join the training to understand much better about Spark. But this is a very brief overview of why Spark is needed. As I told you, this is about iterative analytics, and there is also another reason why Spark was developed, which was related to interactive analytics. As you can see here, and interactive analytics means if some of you who already work on Hadoop, right, who already have worked on Hive or Pig, will know what do we mean by interactive analytics. It's about ad hoc query analysis, right? Normally data analysts would like to query data to find out some issues within the data or find out the patterns within the data. They will try to query some tables, generally write some scripts to get the result of the data. So that's called ad hoc query analysis, and for that also a lot of time data analysts will have were actually facing an issue that when they write a query to join, let's say, multiple tables in Hive will store big data in tables, and if you want to really join those tables, Hive will internally convert query into MapReduce. So again, it is going to fall back to use MapReduce engine to do that. And if you have written one single Hive query, which is in an SQL format, to join multiple tables, internally Hive engine may convert that into more than one MapReduce program. It's called chaining of MapReduce jobs. So that means it is again very similar to what we have understood here. This is job 1, this is job 2, this is job 3. So again, each job will be having MapReduce, map shuffles or reduce, map shuffles or reduce, and that's why each job is going to the disk many times to do the processing, and again there will be a tremendous disk IO. So data analysts were also not able to perform the ad hoc query faster, and that was another reason why they wanted a framework which can let them do ad hoc query analysis much faster, and they don't have to wait for a longer period to complete the operation. So these are the two major motivations why Spark was developed. All right, and these are some of the slides which actually backs up the claim that I have just made, which is, as you can see, we are reading the data from the disk in the map, and then we are writing the output into the disk. Then reduce surface also reads the data from the disk and write the data into the disk. So each stage here, shuffle and sort, we are assuming is part of the reducer only, but each stage passes through the hard drives. So if you have an iterative jobs, you can see every stage goes through the disk. So there is a tremendous disk IO involved in that, and that's the primary reason why MapReduce was not efficient in doing iterative analytics. Okay, so the primary concern was there is a lot of disk IO. Can we do something better and replace it with the memory? So if you can see here, there are two, each iteration has a disk, each iteration goes through the disk, and now we will use memory instead of disk between iterations so that we don't really have to do disk IO at every iteration. Keep the data as much as possible in memory to get better performance. And that was the primary design change that Spark brought in compared to MapReduce. Okay, so again I repeat, Spark is a framework which helps you to process your data much faster than MapReduce. It is a framework which is a processing engine which can replace MapReduce, but that is not really going to replace Hadoop. So a lot of corporates now are using Hadoop as a storage and resource management layer and the Spark as a processing engine. And that's how they are trying to marry both these frameworks to do the data analytics. And that's a current latest combination of technologies to work on big data in terms of storage and processing. Okay, so this is the discussion on why Spark and what is Spark and why the difference between Spark and Hadoop. Now Spark actually builds a lot of ecosystem components, as I have just mentioned here. So if you can see here, this is the Spark ecosystem where you have Spark SQL, you have Spark Streaming, MLlib, GraphX, SparkR. These are some of the ecosystem components on top of the Spark core engine, which is the master component of Spark, which does all the in-memory processing. So they have also come up with a lot of ecosystem component family where if a person doesn't know how to write program in Spark, he can actually write it in a Spark SQL, which expects people to write the analysis logic in SQL query. Internally, the engine would convert that into Spark program and execute it on the SDFS data. Right. Similarly, there is a Spark streaming component, which is another differentiating factor between Hadoop MapReduce framework and Spark. Hadoop MapReduce, by the way, is a framework which gives you batch analytics or batch data processing capability. It is not helping you to do real-time analytics, right? Whereas Spark with the Spark streaming can give you real-time analytics as well. So Spark support both batch and real-time, whereas Hadoop MapReduce is just batch. Okay. Because as a framework, it cannot support real-time, whereas Spark does support real-time as well as batch. Okay, when I say real-time analytics, I can give you a quick use case. You swipe a credit card and I want to find out whether it's a fraud or not. That's a credit card fraud detection, or a debit card fraud detection is a real-time use case, real-time analytics use case, right? The stock price changes frequently and you want to do some analytics on top of that. That's a real-time analytics. Right, you want to, there are a lot of other analytics interesting use cases out there, and they are built using these frameworks, these technologies. So Spark works in the combination of Kafka to achieve the real-time analytics. However, we'll not get into that discussion right now. Now apart from that, we have a component called MLlib. It's a machine learning library of Spark. So all the machine learning algorithms, one of the use case that I explained called clustering is like that. There are many algorithms are developed in MLlib, which is basically these algorithms are written in a Spark way so that they can be easily executed on the Spark engine. Okay. By the way, one thing I would like to highlight, the entire Spark and all its ecosystem components are developed using Scala. Entire Spark is written in a language called Scala, which is a functional and an object-oriented programming language. You can compare it with Java. There is no performance gain you get when you develop program on Scala. So another important a notion of thought that developers would have, if I use Scala, I will get better performance. That's a completely wrong statement. If you use Scala or if you use Java, there is no difference in performance, because both Scala and Java will internally be compiled into a bytecode and which will be executed on JVM. Okay, so both will need JVM, and hence there is no performance difference. But definitely as a developer, you will love Scala more than Java going forward. Even though if you are an ardent lover of Java, you will start falling in love with Scala. I'm actually using the terms like love and all because this is something that I have also experienced. It's really, really, really very easy language to pick up on and to start working on that. It's really concise programming. Developers' work is tremendously reduced by Scala. You can write 10 lines of code in Scala, which may be 200 lines in Java. So that's the difference. However, Java 1.8 and 1.9 onwards, Java is also making an attempt to do a lot of concise programming in Java itself. Java has also introduced lambda expressions, which is more like a functional programming style. So that's a good news for Java developer. However, I'm just giving you a brief idea on this languages. So entire Spark is written in Scala. Okay. However, Spark allows developers to write Spark programs in any of the three languages, Scala, Java, or Python. You can use one of these three languages to write program in Spark and execute it on the Spark. Okay. Now there is one more programming language which you can use, which is called R. R is again a statistical and analytical tool, and we can also call it as a programming language because it's a language itself. And there are a lot of machine learning libraries available in that, but R doesn't really do big data processing. It's not having a processing capability of big data. It does just small amount of data in memory, and hence if you want to leverage a big data processing capability, you can write your analytics logic in R and then run it on Spark to leverage parallel processing capability. And for that, there is a Spark R component developed so that data scientists can write a algorithm in R and integrate it with Spark R to leverage parallel processing benefit. Okay, and they also have graphics library for doing some graph processing systems like Facebook Friends Network and LinkedIn Friends Network. So this is what Spark provides. All right, and this is the advantage of Spark. So this is what I in fact wanted to touch base on in terms of what is Spark and why it is better, and what is the difference between Hadoop and Spark. So this is where I want to end my discussion on covering the topics. We just wanted to keep it at a level where all of you can easily understand why Spark is needed, and then if you really want to understand more, feel free to ask more questions. Shoot out your questions to the email address provided, as well as we will welcome you to join the training, where we will have a great learning and a very detailed learning on this technology. Okay, so with that note, I would open out for any Q&A if you have. So any questions you have, please ask. Richard, if you are there, let's try to collect the questions.
Oh, excellent. And I've already been collecting questions while you were on there. We had a lot of people who are already jumping in. I'm going to do two things. One, I'm going to take over your monitor here for the next 5 to 10 minutes as part of the question.
Okay.
As we have the poll that we always launch at the end. Okay. And I'll let you know when I give you the screen back in case you have something you want to more explain or have some slides you want to show. And then I always take the first question, and with the group this large, we do have a lot of people back there. People are always asking, is there a recording of the session for later? And the answer is yes, we do record all these sessions. If you go to Simplilearn.com and go under support, just send them a note and request, and they'll send you out a link for the recording. It does take up to 12 hours because they do double check them just to make sure that everything came through correctly. So allow them a little time there, and then they'll send that out to you. Also, a quick hello to the California team. We had somebody from California at the beginning saying the California team was saying hello. I'm not sure who that is. And also, Dr. Vera, glad to have you here. Hello back for you from the beginning. On questions, we have a number of questions, and let's go ahead and start with one that was early. Somebody who is just starting their career into the Hadoop and the Spark and the Cassandra and the MongoDB system, what would be your suggestion for them? And we'll start with, like I said, the beginning, and then I have some more technical ones we'll jump into. What would be your suggestion to them as far as certification and training that they'd want to go through? Specifically, Hadoop, only Pig Hive, then to Spark, and then to Cassandra MongoDB with a question mark after it.
All right, yeah, that's a very good question, and in fact that is very important question for everyone who wants to get into these technologies. So you should definitely get into learning the systems in this manner. You don't really, what I really would like to advise is, don't just go behind the technology names, whether it is Hadoop or Spark or anything, but try to understand the fundamental concepts that you need a distributed file system understanding. You need to know how data gets distributed. So you should be familiar with, and you should have a good hands-on experience with how data gets distributed in the system. So that should be one topic in your list, which is distributed file system. Then once you store the data, you should have one topic in your list which says, how do I process this data in a distributed manner? So you should be learning one processing engine. That is another topic. And the third topic would be resource management. And then on top of that, you can add later on some of the high level components which you have mentioned, like pig, hive, and all, which are obviously needed to be used. But then not a single company can give you a guarantee that we are having pig and hive both, or we are using pig or we are using hive. So don't ever develop your skill, a core skill in pig or hive. Rather try to focus on these core components like distributed systems, distributed processing engine, resource management capabilities. Once you understand, once you have once you know these components very well, then building skills on top of this will be easier, right? So if you know this, you will have a better chance of getting good opportunities. Now coming back to the distributed file system and the processing engine, currently in the market, SDFS, which is from Hadoop, or NoSQL databases, which could be Cassandra or MongoDB. You can pick up all of them or any of them, but be very careful. You need to first understand the difference between SDFS and NoSQL. There is a lot of difference. You need to know when to use what. But I would suggest understand SDFS thoroughly and understand one of the NoSQL database thoroughly. Coming back to the processing engine, Spark no doubt is the hot cake right now in the market, so learn that, right? And to learn Spark, you should also understand a basic of MapReduce. You should not ignore MapReduce because the way it processes the data is using divide and conquer, and Spark also uses that. In fact, you'll be surprised to know that you can write MapReduce program in Spark. So it's better if you know some of the concepts of Spark so that you can easily appreciate those concepts in Spark better, right? So you should know a little bit on MapReduce as well. And then coming back to the resource manager layer, you should learn Yarn from Hadoop or Mesos. One of these two you should have a very good understanding. That's it, and you are set. You get a good job. All the best.
And start earning some good money on that. That's always exciting. Not that it's all about money. A lot of times it's also about enjoying your work, because I love playing with data myself.
Right.
We have a lot of, it's hard to sort through all the questions because there's some that are very similar. Let me see if I can group some of them together. Let's go into this. Can you go a little bit more as to how Spark and Hadoop exist together on the same system, how that they leverage each other? It's kind of like, is it replacing it? Is it, are they in competition with each other? And one person asked, do they exist in the same project? And if so, when will they do that? Can you go a little bit more into that part?
I think this is something which really need a lot of time to explain, but I would still try to explain it quickly. So for example, any Hadoop or Spark is actually a master slave architecture. So you can see here, by the way, can you just help me share the screen?
Hey, if you want, I can't like close and open up the poll, and I'm supposed to keep it open for like another a little bit longer here. Do you want to come back to this question?
Yeah, right. I think it's a good idea. Yes, let's come back to this question later.
Okay, so we'll come back to that a little bit more and how the two function together and separate from each other. And then one of the questions that came in is also hardware. Always an interesting question because it's very hard to pinpoint hardware. Usually, when I've seen this question come up, I have to ask specifically, have you had a project where you've seen the difference? What is the difference in cost when you set up a Hadoop file system and then you want to do the Spark either on it or running on its own as far as expense and hardware and setup?
Right. It's definitely a varied school of thought that anybody would, first of all, have a question when it comes to memory, in-memory processing. Anybody would have a question that, does it really store all the data in memory? And if yes, that means I need a lot of memory. That means my cost is going to go high. So do I need a lot of memory in my, do I need to upgrade my cluster? Do I need to spend more money? Well, the answer is Spark performance has been tested out on the same resources where Hadoop MapReduce was working, and in fact, there's a company called Databricks which has actually set a world record in sorting terabytes of number using the same cluster resources, right? Where they are actually able to do it much faster in Spark than any other processing framework on the same resources. They did not increase memory or CPU or anything, right? So that set the benchmarking that you don't really need to increase your RAM or processing capability if you want to run Spark on the same cluster where Hadoop is running, right? Having said that, if you give more memory to Spark, Spark can leverage it better. So it definitely gives you better performance. But it doesn't mean that you need to have more memory if you run Spark. I hope you get the clarity.
Excellent, thank you. Yeah, so as I know that I work with small businesses, so that's like the first question. One of the questions that I always get asked is how much does it cost? Which is a very hard question to answer. There's no easy answer for that. Tapas had a question, and I'll go ahead and answer this one. Does Cloudera has the IDE for Spark? Tapas, Cloudera install usually by default, unless you change it, includes Spark. So when you run a Spark single node install or anything like that, you'll have or a Cloudera install for Hadoop, you'll have Spark on it. Let's see, is there a difference between Hadoop and data science? Where is the connection between them? That's from Benson. So Hadoop and data science, how are those related?
Oh, there is a big difference actually. So Hadoop is a technology and data science is a concept, right? It's not a technology. It's actually it's a very vast area which has data visualization, data engineering, machine learning, statistics and probability. Everything falls under that. It has a major components inside it, right? So data science is anything that you want to do with data is actually part of data science, right? It's not only that those mathematical geeks who do that work, they are only doing the data science work. In fact, anybody who does ETL work, anybody who does data analyst work, anybody who tries to play with data, churn out data to generate some reports, every activity is considered under data science. But data science has various streams, and one of the stream is called machine learning. That's where a lot of focus, and that's where people or corporates focus more, because they want to leverage interesting patterns out of the data to remain competitive in the business. But apart from that, there's a data engineering, which is one of the big streams where we have already data, we want to process data faster, we want to store data faster. So that data engineering is one bucket, which is one branch of data science. And to achieve that, we have Hadoop as one of the technology which enables us. Spark is another technology which enables to do faster processing, right? So data engineering has technologies which is Hadoop and Spark, and data engineering falls under data science.
Excellent. Yes, and I could see, because you always see big data, Hadoop, and data analytics is how it's almost always when you do searches. But the data analytics is separate. That's excellent. Well said. From Narander, he says, hats off to you, Jay. MapReduce explained so simple and straight. So you had an extra point there from Narinder. And then he also, let's see. Bear with me for just a moment here.
Thanks.
Let me go ahead and close the poll now, and then hand the screen back over to you. We can go back to the question on Spark and Hadoop and how they connect and fit together. There we go. I went ahead and returned your screen to you. That seems to be one of the big questions. Is it Spark versus Hadoop, or is it Spark in conjunction with Hadoop? How do those fit together and connect?
Right. So this is a small diagram that I'm drawing here. So normally in this cluster, right, whether it is Hadoop or Spark, generally corporates will not have separate clusters. They will install Hadoop and Spark together on the same cluster, right? So you have a master machines, and now there are various topologies, and we're not really going to discuss them. But there is a master slave is a fundamental architecture that these guys follows. These two frameworks follows. Okay, so you have these 5 processes which are part of Hadoop: name node, data node, secondary name node, which makes up the SDFS, which gives you the storage and processing, which in fact gives you the storage and reading of the blocks that you store in SDFS. Basically, any data that you store in SDFS, you have these three processes which will take care of that. When I say process, they are nothing but they are Java programs which are part of Hadoop libraries. Okay. Apart from that, you have Resource Manager and Node Manager. These are two more Java processes from Hadoop, which helps you to do yarn and MapReduce, which means it helps you to do resource management and the processing of data. There is also one more process which is called Application Master, which is not a daemon process, which is initiated only when it is required to process any data. However, right now assume that these are the 5 processes which is running in the cluster when you install Hadoop. Okay, now coming back to Spark. Spark has Spark Master and Worker. These are the two processes of Spark. There is Spark Context as a driver which will be initiated for every Spark program. So when you install Spark, you will have Spark Master, right? I don't have enough space, so sorry for my bad handwriting. There is a Spark Worker which is running here. So Spark Master and Spark Workers are coexisting with the name node and resource manager and data node and node manager. So you can see that name node is a master and data node is a slave for the HDFS. Resource manager is a master and node manager is a slave for yarn and MapReduce. Spark master is a master and worker is a slave. And all masters will run in master, all slaves will run in slave. That's how you should understand right now. As I said, there are more master machines you install for better high availability of the master and better resource management. You also do federation on the name nodes for faster performance. But as I said, there are different topology we need to consider when we detail out the architecture. But right now, you just assume this way. So Spark and Hadoop can coexist together on the same cluster. It does coexist, and this is how you should visualize it.
Excellent. Excellent. Thank you. Let's see. We have got a question from Sam, and you can correct me if I give him the wrong information. He says, what type of computer should be used for learning this? Sam, there's a lot of different options. Generally, it's installed on the Linux operating system. That doesn't mean you have to go buy a Linux computer to do that. You can download VirtualBox, and both Cloudera and Hortons have a version of both Hadoop with Spark already bundled with it for what they call a single node install. It's definitely not big data, but you can actually use it and see how it works. In our classrooms, in the developer classrooms at Simplilearn, you have access to a cloud lab where it is a 5-node setup, and you can actually see how that functions, and that's part of the cloud lab in our learning sessions. And then there's also just recently, or not recently, it's actually been around for a while, there's also Docker setups. A little bit more complicated, but in some ways they actually have a little less resources and strain on the computer. All of those can run on a Mac. They can all run on a Windows. When you log into Cloud Lab, you can log in. You're logging in through your browser. So I'm on there all the time, and I have a Windows PC, and we have a number of students who also have Apple machines. I also have a Linux computer that I've actually installed the Hadoop on. So all of those can be used depending on what level and what you have available. Generally, you want to have probably 12 megabytes on the computer. I have 8 on one of mine, and it runs slow. We do have some people that run all the way down in 6 doing the VirtualBox. Those, you want to run a cloud lab at that point. You want to be online someplace else. So yeah, hopefully that got Charu's question answered about 8 gigabytes memory. It'll run. That's sufficient to run VirtualBox, but it's going to run slow. If you can, you want to have 12 gigabytes. Let's see. I hope that answered that. Do you have anything else on that as far as what kind of computer or setup they would need as far as practicing?
Well, I think they would need any Windows based or a Mac OS based laptop is fine. But if they are really planning to install Hadoop cluster in the local machines, if they take Apache distributions, then the 4 GB RAM is enough. Okay. But if they take Cloudera or Hortonworks Sandbox, then they need at least 8 GB RAM. For Hortonworks, I would prefer 16 GB. For Cloudera, 8 GB is enough. Okay, so that's the RAM configuration. In terms of CPU, dual core CPU should be enough for your machine. So that's the 64-bit operating system. So these are the three basic hardware requirements that you should have.
Excellent. Yeah, that's what I've been working with the lab since I do a lot of work in the background, and that's what I've had. To give you guys an idea, if you're running VirtualBox with Cloudera on it, which you can do on a computer, on 8 gigabytes RAM, it takes about 4 minutes to load. So you can see why you really want the 12 gigabytes RAM if you can. You know, if you go in the dual core processor. If you have a quad, that's even better. If you have a four core processor. From Vignesh Kumar, choosing a career in Spark better than Hadoop, or Hadoop alone is enough? Will learning Spark enhance my career growth? Which has more package in the current market? Yeah.
Well, I think that's a very straight, direct question, and probably why not? So. Well, I would, as I was explaining, that the industry is actually focusing towards Spark more and more in terms of as an option of a distributed processing engine. So definitely, if you have a good skill on Spark, there is definitely a very, very valuable skill right now in the market in terms of big data processing. So you should definitely aim for Spark. Hadoop is also needed because a lot of companies have already done a lot of work in Hadoop, so it's not going to go away. And as I said, SDFS and YARN is still being used widely, and that's why you should have both the understanding. If you have combination of Hadoop and Spark, you can throw us a party by getting a good salary.
Excellent. I like that. Yeah, I want the party. Don't forget to call us and invite us.
Right.
We have, let's see, and I'm not, this one throws me for loops. I'm not sure if I understand the question right, but I'll just go ahead and read it to you. How would you say compare MarkLogic, he put it as all one word, MarkLogic, how WR, does it fit in the Spark framework, or is MarkLogic, is that a standalone project? Which big data technology is best suited where a lot of CRUD capitalized operations are involved?
Okay, so I think I would probably not be able to answer it clearly because even I am not really very sure. I don't have much idea about MarkLogic. But when it comes to the CRUD operation, I'm assuming that he's talking about a lot of ETL kind of operations. If that is his question, then definitely Hadoop and Spark both are very suitable components where you can load the data from the external sources into Hadoop and then process it via Spark and generate reports. Now, for reporting tools, you need to use any BI tool, which could be Tableau or ClickView, and integrate it with your Hadoop storage systems. And for getting the data into Hadoop, you should have tools like Scoop or Kafka to get the data in real time or in batch from external sources. It could be database, or it could be logs, or it could be file system, it could be Twitter kind of source into Hadoop. So you have to consider all the various big data components to create this pipeline, which helps you to bring the data from external source, get it into the SDFS, process it via Spark, and then generate reports using BI tool. That's how companies are using it. So if that is your question, I believe this is the answer for that.
Excellent. Yes, that's what I would come up with. That sounds really good. So we have time for maybe one or two more. We'll go a little bit more over. Just a quick reminder, because I had a couple people ask again. Yes, you can get the recordings afterward. You do need to go to simplylearn.com and just request them from the support staff there, and they'll email you out the link. It does take up to 12 hours. Let's see, there was a question on Hive. Unfortunately, I think to really get into the difference of Hive and all the different queries in Hadoop would take too long. Apologize for that. Hive is specific to SQL, or it's actually called HQL, Hive query language. It's very similar to SQL. Let's see, recording of sessions. What books would you reference for learning? What would be the top references you would suggest for people, in addition to taking a class at Simplylearn, for them to go and research and look a little bit more in depth as a reference?
Spark.apache.org. That's the best website. you can actually get a lot of materials and online recordings from various sources, and I would really not discourage you to go through them. They are very useful, but then the best, and in fact in Spark, Apache has created the best documentation, and it's very detailed, to the date, latest documents. So you just go through different versions and read about everything. In fact, they have also given you the examples on every concept, and those examples are also mentioned. Let me just give you a quick idea on Spark. If I just want to kind of give you a premiere of what I'm really trying to tell you, this is what we are trying to say. So you go to the documentation. In fact, you should just start from Spark.org website, and then here, we are basically trying to explain you that you need to go to the documentation, go to the latest release, and then it comes to this programming guide. So you have various components. You can start with any component, whatever you want to understand. For example, data frames. So if you go scroll down, every detailed components are mentioned along with the code. So you can see there is a code written in Java or Scala or Python, right? So and R as well. So in fact, it's a very good tutorial for anybody to start and also get a very advanced level of understanding.
Excellent. And then, yeah, go to the source. That is, I definitely reference that regularly.
Yeah, GitHub repository. They have actually provided a lot of source links as well in the same website, so you can go to them as well.
All right. And then from Manoj, I'll see if I can answer this question. If I opt for the full training, how long will I have access to the labs after the training is done, etc.? Manoj, it depends on which setup you sign up for. If you do the most basic one, if I remember correctly, it's 90 days afterward. I'd have to look it up. But you'd want to go to the Simplilearn site and just, there's a pop-up and you can actually request that from the little chat window that comes up, and someone will answer that question right away for you. It is more than long enough to go in there and play with it for a while, and then once you have a handle of it on there, definitely, I actually know one of the people we work with, he walks into working with us at a job interview, he'll take his laptop in and open up his virtual box and actually show them stuff right then and there on his laptop. So, having both is really important, being able to access the lab and having it, if you can, if you have the resources. Not everybody has the money to go buy a 12 gigabyte fancy computer when they start a new class. But you do have plenty of time on the labs, and then there's also, sometimes we do extension. If you do the master's programs, you'll have even more time. We have people who sign up for I think there's a year program you can even sign up for that goes through the whole year. So it just depends on what you sign up for. I believe we're going to run out of time here. I want to thank Narinder. He gave us a definition of mark logic, because I didn't know what mark logic was. Database to integrate data silos. So I'll probably look that up. I'll probably go Google that when we get offline here, just so I can have learned something new today. I believe that's, let's see, Simplilearn placement. Let's take one more question. Does Simplilearn give placement to their students, and with which companies do you have ties from? We don't have, as far I know people, there's different areas, and I myself have not had job placement through Simplilearn. The companies I've looked at that do that also charge 20 times more. So there's a difference in price, and there certainly is a connection with the staff where they do have, sometimes you talk to some of the teachers, and I know they'll reference you and help you with what direction to go in and what places to go to look for work. So we do have that depending on which teacher you have, and they're really good about it. But there's not like a specific placement in the class for that. Do you know anything like that, Jamin?
Yeah, even I have not heard about it, so I don't think they have. But then, yeah, it's a good idea to check with the Simplilearn team to get a confirmation on that.
Correct, and I've actually suggested them doing more kind of stuff like that. So, and that's the same thing that Sanjit, yours is kind of the same question. So they don't have a specific placement afterwards, but I do know a lot of the teachers, especially if you ask them, they'll start telling you where to go, where to post your stuff, who to talk to. In the programming industry, I'm finding in my area, it's so important to get out there. In fact, I'll be doing a free lesson in a month specifically on MapReduce and Spark for the local companies and businesses because they asked for it. That gets my name out there, and then they actually get to meet me before they hire me and before I do work for them. So there's a lot of different ways to get out there and get your job placement. Definitely, whatever teacher you choose or whatever classroom you come in, ask them, and they'll send you in the direction to forums to post and things like that. I believe we are running out of time here. I'm going to go ahead and wrap this up, Jamin, if that's all right with you, unless you have anything, last minute thing you want to go ahead and ask or mention or bring up.
No, I'm fine. I'm fine.
Excellent. I want to thank everybody for being here today, and thank you, Jamin, for being here. We look forward to seeing everybody in our classrooms.
Yep. Thank you, Rishad. Thank you. And thank you, everyone. Thank you for listening us patiently. Thank you.
Excellent. All right, take care and enjoy your day today.